So as we mentioned before, one of the critical pieces of studying geometry and about geometry in general is that it deals with the interactions and the relationships between different types of geometric objects. Now, so far in the course, we've seen the building block foundational objects, the point, the line, the plane, and space. We've also used those objects, and specifically, we have used lines and pieces of lines to create segments, rays, and angles. And so this video is going to go through the relationship between different types of angles. You may find as we go through this video that there are some things you have heard about before or maybe even worked with in previous math classes. We're going to go through some rigorous definitions of that, get to a definition you may never have heard of before, and get a chance to pause the video, copy some things down, and do some practice problems. So the first type of relationship we're going to talk about between angles is what happens when two angles form a straight angle when added together. So here we have angle 1 and angle 2 that are being used to create the red line that is a straight angle. Now angle 1 and angle 2 share a common ray, that is the blue line there, and they are adjacent angles. So because they create the line, we call them a linear pair. A linear pair is a set of adjacent angles whose non-common sides are opposite rays. In this case, in a linear pair, it's easy to see that using angle addition, when angle 1 and angle 2 are added to each other, they're going to create the same number of degrees as the straight angle, which is 180. Any two angles whose measures add up to 180, whether they are linear pairs or not, are called supplementary. And the measure of angle 1 plus the measure of angle 2 in this case, as you can see in the upper right corner, is going to be equal to 180 degrees. So go ahead, pause the video, copy down the diagram of the straight angle with angle 1 and angle 2, the definitions of linear pair and supplementary angles, as well as the formula in the top right corner. Come back when you're ready to see an example of its use, and then move on to the next set of angles. So the application of supplementary angles is exactly as easy as it seems to be given that formula. If we know that measure of angle 1 is 35 degrees, then all we need to do to calculate the measure of angle 2 is realize that 35 plus the measure of angle 2 is 180. I'll call this 35 plus x because that's what we use. You subtract 35 from both sides, subtract 35 from 180, and get that this is 145 degrees. And that's how we use supplementary angles. Now, if two angles are adjacent and they add up to another common type of angle, maybe they can add up to a right angle. They don't even need to be adjacent angles necessarily to add up to the same number of degrees as a right angle. In this case, angle 1 and angle 2 are adjacent angles. They share a vertex, they share a common ray, and their non-common sides are perpendicular. In this case, we call those complementary angles, angles whose measures add up to 90 degrees or to a right angle. And the measure of angle 1 plus the measure of angle 2 is 90 degrees. Go ahead, pause the video, copy down the diagram with angle 1 and angle 2, the definition of complementary angles, as well as the formula that the measure of angle 1 and angle 2 is 90 degrees. Come back when you're ready to move on. So in this case, the application of complementary angles is exactly as easy as the application of supplementary angles is. If we know that angle 1 is 62 degrees, then in order to figure out angle 2, if 62 plus x is equal to 90, then subtract 62 from 90 and get that angle 2 is 28 degrees. So those two definitions, supplementary angles and complementary angles, are things that you may have seen before in previous math classes. If you have, that's great. The first half of the video is relatively easy. If you haven't, that's also totally fine. Now we know. Now I'm going to give you a chance to practice finding complementary and supplementary angles for yourself. In the column on the left, you're going to find the complementary angles to those ones that were given, and on the right, you're going to find the supplementary angles for the ones that are given. So pause the video, calculate the complements or the supplements for those angles, come back when you're ready to see the answers, and move on to one last type of angle relationship. So remembering that the sum of complementary angles is 90, 90 minus 24 is 66 degrees for the first one. 90 minus 48.5 is 41.5 degrees. And 90 minus 45 is 45 degrees. So in this case, a 45-degree angle has the unique property of being complementary to itself. Looking at the supplementary column, we remember that supplementary angles sum to, or the measures of them, add to 180 degrees. 180 minus 45 is 135 degrees. 180 minus 127 is 53 degrees. And 179.5 taken away from 180 is 0.5 degrees. Yes, we have partial angle measures because angles are not continuous. They're little ticks along the protractor. So there are measures between a whole number of angles. The last type of angle relationship we're going to talk about in this video is what happens when two lines intersect. In that case, we create things that are known as vertical angles. Those are angles that are made by intersecting lines and do not share a ray. Go ahead, pause the video, copy this down as well as the highlighted parts of the diagram. Come back when you're ready to move on. So angles 1, 2, 3, and 4 are related in a lot of ways. Angles 1 and 2 have a common ray and are a linear pair because they make up the green horizontal line. Angles 2 and 3 are also a linear pair. They make up the diagonal line, and they have a common ray going off to the left. Similarly with angles 3 and 4 and with angles 4 and 1. But angle 1 and angle 3, although they have a common vertex, do not share any rays, and they are made by the same set of intersecting lines. And both of those are critical. They need to have no common rays, and their rays must belong to the same two intersecting lines. When that happens, they are called vertical angles. So angle 1 and angle 3 are vertical angles, and angle 4 and angle 2 are vertical angles. We can highlight those a little bit differently, like this, and say that you can just look across the intersection. Now this gets a little bit more complicated when you have more lines that are intersecting at a single point than just one. But remember that vertical angles must be made by the same two lines, and no matter how many lines are intersecting at a given point, they cannot be vertical if they are not made by the same two and only two lines. Well, something you may have guessed based on the fact that we have a bunch of linear pairs here is that vertical angles have a particular size relationship, and that's that vertical angles are congruent. This is something that we call the vertical angles theorem. Remembering that a theorem is something that can be proven true, you are actually going to prove this true as a part of your skills practice after watching this video. But for right now, you're just going to copy down the vertical angles theorem, often abbreviated to VAT, that vertical angles are congruent. Come back when you're ready to see your last set of practice problems. Well, it may not seem like vertical angles show up in many places over the world. Anytime that you have intersecting lines, intersecting beams, intersecting skis, for somebody who's doing tricks on skis, they create vertical angles. So here are your last practice problems. You're going to find the angle measurements of any of the missing angles based on the information that you have. Go ahead, pause the video, come back when you have done those practice problems, are ready to see the answer, and to wrap the video up. So for number 1, we know that angle 4 is 65 degrees. We know that angle 2 is vertical to angle 4, so by the vertical angles theorem, it is also 65 degrees. And now we have to rely on the fact that we know that angle 1 and angle 4 are a linear pair, so they are supplementary. And 180 minus 65 is 115, so angle 3 is also 115. In question 2, up in the top right, angle 1 is a right angle, which means all of the angles of that intersection are right angles, so that's easy. They are all 90 degrees. That is what happens when you have perpendicular lines. In number 3, down in the lower left-hand corner, we know that angle 1 is 30. Angle 2 is the same as angle 3, and the red lines make a right angle. Now, no two of these angles are complementary because angle 1 plus angle 2 is not 90, angle 2 plus angle 3 is not 90, but angle 1 plus angle 2 plus angle 3 is 90 by angle addition. So when we take the 30 away from 90 degrees, we find out that together, angle 2 and angle 3 must be 60 degrees, and if they are the same, then in fact, all three of those angles are 30 degrees. And when an angle is cut into 3 equal segments, it is called trisected, like an angle cut into 2 equal segments is called bisected. And then finally, for number 4, we know that angle 1 is a right angle. Angle 4 is 25 degrees. That means that angle 2, or angle 3 rather, made by the blue intersecting lines is also 25 degrees. And angle 2 and angle 3 also add up to 90 because we have a perpendicular intersection there, and 90 minus 25 is 65 degrees. So that is the introduction to the basic types of relationships between angles: complementary angles that add up to 90, supplementary angles that add up to 180, and vertical angles that are made by intersecting lines, the angles that do not share any common rays but have the same vertex and whose rays create two lines and whose measures are congruent.